Okay, so part of my project was to go into the honors physics class while they were going through the broken appliance lab and to help them out a bit. So when I noticed Asa disassembling this radio slash tape player, I noticed something interesting on the circuit board he had pulled out. If you can see a little loop of wire right here, a little coil of copper wire, and that's actually an inductor, and it's hooked up to this capacitor right here. And when a capacitor and an inductor are hooked up in a series, it's actually called an oscillator, and I'm going to show you a bit more about those. So as I mentioned before, an oscillator is essentially a capacitor and an inductor hooked up in series. So the way this works is that the capacitor, which in this case is carrying a positive charge on the top and a negative charge on the bottom, discharges its charge through the inductor, which builds up a magnetic field in the inductor, which is essentially just loops of wire. So when the capacitor finishes discharging through the inductor has built up a magnetic field, and the inductor has stored energy in this magnetic field. Now once the capacitor is fully discharged, the inductor will try to keep this current going because inductors resist a change in current, and the energy to do so will come from the magnetic field that the inductor has built up. So the inductor will keep this current going, and once the magnetic field is broken down, the inductor will have charged the capacitor up back to its original voltage, but with opposite polarities. So it would be positively charged on the bottom plate and negatively charged on the top plate. Now, this is essentially the same thing, the exact same as our starting circuit. So the capacitor would again discharge to the inductor, which would again build up a magnetic field and would again recharge the capacitor. And in theory, this could continue to oscillate forever, but in reality, the charge would eventually drop to zero because the wires would dissipate some of the energy each time the capacitor was recharged because they have resistance. And essentially, that is how oscillators work. So now that we know how oscillators work, we can take a look back at the original appliance, which was a radio, and we can see how the oscillator works in this radio. So just taking another look, we have, again, the copper coil, which is the inductor. We have the capacitor, and an inductor and capacitor in a series can also be called an oscillator. So the way that this works in the radio is that I already talked about how when you discharge a capacitor, it stores energy in the magnetic field of the inductor, which then recharges the capacitor. The frequency at which this happens is called the resonance frequency of the circuit. So, and this is called the resonance frequency of the circuit. And this frequency is dependent on the capacitance of the capacitor, the inductance of the inductor. So when you tune the radio, you change either the capacitance of the capacitor or the inductance of the inductor. And in doing so, you change the resonance frequency. And what this does is that when the signal comes in from the radio, it's got the audio signal, which is talking, music, whatever, on top of a carrier signal. And when the carrier signal matches the frequency of the carrier signal matches the resonance frequency of the oscillator, then the radio essentially subtracts the carrier signal's frequency from the frequency of the overall signal, and can basically output through the speakers an audio, which is again a voice or music. And essentially that is how oscillators are used in radios.